Morning, everybody. Thanks. Thanks. This is a pretty big crowd, so thank you all for coming. Thank you for making us your first breakout session choice of the 2017 Tableau conference. We're really excited to be talking to you about visual analysis today in this talk because visual analysis is one of the things that got us both really excited about using Tableau in the first place. We're not really IT server people. We're really about doing analysis, and that's why we'd love to talk to you about this today. So we're going to try and achieve three things in our session. First is to get you excited or re-excited about doing fundamental exploratory analysis. The second is to give you some tips in Tableau that you can hopefully take away and take back to your jobs. And the third is to give you a bit of an insight into Spotify and how we work as an insights team there. All right, we're working. Okay, super obligatory legal notice that my legal team told me I have to tell you. We will be showing you some data today. All of this data is completely altered or simulated. It does not reflect Spotify business metrics in any way. This is also flagged as a beginner's session, so if you were hoping to learn how we make Discover Weekly, sorry, that's not going to happen either. All right. So time for some introductions. So my name is Peter. I'm Director of Product Insights for Revenue at Spotify. I've actually been using Tableau since 2012. This is my 6th Tableau conference, and very excited to be here talking to you about the things that got me excited in the first place. Before I'd ever made a dashboard, before I'd ever heard of the words business intelligence, I was using Tableau to explore data and find new insights. And I feel that it's quite important that, as a community, we often bring that back to the fore, because sometimes I feel that message actually gets a little bit lost. Okay. Oops.
And my name is Tatiana. I'm an analytics manager at one of the revenue teams at Spotify. And this is actually my first Tableau conference, and I'm super excited to be here. And I look really excited on this picture because I finally found a pair of noise-canceling headphones that actually work. So there are two things I really love: art and data analysis. And I think exploratory visual analysis is where two intersect and really shine. The process could be so informative and so creative, and it can result in some really beautiful visualizations. So Peter and I are both part of a team called Product Insights, and it was formed out of user research and data science disciplines about 2 years ago. Oops. And we created this team because we realized that in order for us to build truly great products for our users, we really need to be able to understand users from many different dimensions. And we are now a global team of over 80 people, and this is all of us at our most recent offsite in Bushwick. So the mission of our team is to enable evidence-based product and design decisions through all stages of product development. And because we have this unique set of skills from user research and data science, we're able to do some pretty complex insights and represent our users in all of their multidimensional glory in the design and product process. And we do this using a variety of methodologies. We look at small data that is collected through interviewing and observing users. And we look at huge data sets that contain hundreds of millions of events that we collect by tracking everything our users do in our app. We try to understand user attitudes, their emotions, what motivates their behavior. We look at the data as a snapshot in time, and we can track user behavior over long periods of time. We look at user-reported data, and we can compare it to what we observe our users do. We use a variety of qualitative and quantitative methodologies, and sometimes a combination of both, to really understand why users are doing something and also enumerate their behavior at scale. We even sometimes observe our users in a lab, and then we can compare it to what they do out in the wild. And so today we'll teach you a pivotal step in our insights process at Spotify.
Cool. We seem to have also developed an auto-forwarding computer within the last 5 minutes. So I may have to quickly press back a couple of times. This is what our insights process looks like. We start off, as anybody would, with a preparation stage, understanding the problem and preparing the data. We then focus on exploration. So that takes 2 methods for us. It's exploratory analysis. What the heck is going on? Excuse me, I'm going to get rid of that. That might help. OK, I can slow down now. So we look at exploratory data analysis, and we also look at qualitative user research. Sometimes the exploratory data analysis will lead to questions which lead to user research. Sometimes it happens the other way around. So we might do some user research, and we want to understand the scale that something's happening at, which we can only do with data. And then finally, we get onto the last stage of the insights process, which is sizing, experimentation, and monitoring. So that's when we will start to do analytical work, A/B testing, and also building out of dashboards. Of course, not shown here is like communicating back to our stakeholders, but we'll save that for another time. OK, so we're here to talk about exploratory visual analysis. We're going to call this EVA for short throughout this talk. What do we mean by that? We are not entirely sure if we just made that term up or if it's a real thing, but you've probably heard of exploratory data analysis, or EDA. So we're just focusing on the visual component, so that's why we're calling that today. All right, so a quick history lesson for you in the room before we get too far. So back in 1977, a famous statistician called John Tukey, who worked at Bell Labs, wrote this seminal book. And Tukey at the time believed that basically statistical methodology had become far too focused on hypothesis testing and not on insights work to generate new hypotheses. And this is why he kind of talks about the need for exploratory data analysis. And if you get hold of a copy of this book, it's quite expensive actually on Amazon, it's about $100, but it's a classic, so you should get it. If you get a copy of this book, you will see it is full of lots of charts that are drawn by hand. And of course, drawing things by hand is a very time-consuming thing to do, but I think it really shows just how important the power of visual analysis is that people would take the time to do that back then. Of course, many of you who have been to conferences like this before will have seen this chart 100 times and may be bored of it by now. It may be new to some of you. This was a guy called Anscombe who in 1973 showed that 4 data sets with identical means, variances, and fitted linear slopes could have very different looking patterns when you looked at them visually. And although this is becoming a bit like old news by now, I still think it's really important, especially as we have truly big data and the risk is to just dive in and do statistical work straight away. Of course, in 2017, we have Tableau, and using Tableau is a whole lot more fun, in my view, than trying to draw a box plot by hand. So everyone, and everyone in this room especially, who works with data can and should be using these techniques. And I don't think it matters if you're working in business intelligence and reporting, if you're insights and data science, or even if you're at the advanced end, of machine learning and predictive analytics, or if your job is to be interpreting data to make decisions. Understanding the process of exploratory analysis and where it fits in the larger scheme of things is really important. If you're wondering why, well, quite simply, if you don't do it, you may not see the forest for the trees. And we think EVA has some seriously good benefits.
So digging into the data before you dive into dashboarding or modeling can greatly improve the accuracy of your analysis by surfacing various data quality issues and anomalies that could be impacting your results.
By doing visual analysis, you can also avoid falling into traps with your data. You can spot red herrings, and you can test assumptions about your distributions.
Cutting through the ambiguity of data to prioritize research questions can be a daunting task. EVA can be very helpful at focusing analysis on the most important things first.
And if you're in the business of building dashboards, it's really important that you build dashboards that aren't just pretty, but that they also have a lot of impact. I've seen some people describe a good dashboard process as, starting off to think about drawing it out by hand first and thinking about the layout. In my view, that's the wrong thing to do. You should explore your data first, understand what the key trends and patterns are, and what's the key filters and the functions that you can use so that when you build a dashboard, you know it's going to have impact and be able to provide insights.
Before running an experiment, we need to come up with a testable hypothesis. And EVA can be used to form these hypotheses by surfacing relationships and correlations in data. And this one is really important to us at Spotify because we run a ton of A/B tests.
And doing EVA can also unearth things that you didn't expect, things that are very unusual and you didn't know before in your data, and things that sometimes you can't answer with data, and that can lead you to want to carry out qualitative research. And as we mentioned before, that's exactly why we pair up our data science team with our user researchers at Spotify to try and get the full view of what's going on.
So in this next section, we will walk you through a few moments in data work where EVA plays a key role, and we will show you how to do this in Tableau. Some of the moments we're going to talk about is how to look at data quality using EVA, how to understand the shape of your data, how to surface relationships and correlations, how to better understand patterns and trends, and how to spot outliers and quirks. And so before you do any insights work with your data, it's very important to make sure that you're working with the data of good quality. Because no matter how rigorous or sophisticated your methodology is, if you're basing it on bad data, your results are just not going to be reliable. So some of the questions to ask in this section when you use EVA to verify data quality is the row what you think it is? Do you have as many records as you think you have? Are you missing any data? Do you see things that just can't be true? Are there any number format problems that could affect your insights? And one of the easiest ways to check data quality is to simply plot your data. So let's say we all work for an international company, and we're trying to understand how old our users are. And because we're available in many markets, we'd like to understand how old users are for each market as well. So let's say we pulled 10,000 records randomly that have user IDs, country, and age, and these are supposed to be unique records. So first, let's make sure that everything looks like it should be in the right format. So we have user IDs, they're encrypted as they should be. We have age, and then we have country abbreviated as 2 letters. And it also looks like we have some nulls, which we can get back to later. Let's first make sure that we have as many records as we think we should. So here looks like 10,000, which is what we were aiming for, so this looks good. But now let's make sure that these records are unique. So I can do that by clicking Option and dragging user ID to rows and picking count D user ID. And so here, it actually looks like we may have some duplicates in our data because we only have 9,879 unique records. So let's dig in a little bit more and see if we can figure out where the duplication happened. So I'm just going to duplicate this sheet and look at the number of records per each user. So I'm just going to drag user ID here. And then I'm just going to use text instead of the bar chart so I can see more records on the page. Now I'm going to sort from largest to smallest. And here I see that there are a few users up at the top that have 12 records instead of 1. So this sort of helps me understand where the error was made in the query, because these are the users that have many duplicated rows. So let's say I go back, fix the query using this information, and now I have my improved data set. And here I check it again, and I see that I have 10,000 records and 10,000 unique records. So now we're good to go. And this, by the way, is a really great first sheet to have when you're doing analysis in Tableau. So now let's look at average age. So here I'm just going to remove these 2 metrics and add age, but I want it as an average, so I'm just going to change to average. And I see that our users are about 32 years old on average. And now I'd like to see what that looks like for each market. So, but before I do that, I'd like to look at the number of records that we have in this data set for each market. So duplicate this again. I'm just going to look at country and number of records for each country. I'm just going to sort it from largest to smallest. So here I see that US has the largest number of users, and then other markets that are pretty large are Great Britain, Mexico, and Brazil. And let's look on the other side. So here I see some of the nulls we saw earlier, so I'm just going to go ahead and get rid of those nulls. And one of the ways to do it is to just duplicate country dimension, drag it to filter, and exclude nulls. And the other thing I see here is that we have quite a few markets with very small number of records. And because we're trying to figure out average age for all markets, for each of those markets, we need to make sure that we have enough records to make a reliable estimate. So I'm just going to go ahead and remove all markets that have less than 30 records in them. And I can do that by dragging sum of records to filter and removing all markets with less than 30 users. So now we have a lot less users in our data set. A lot fewer markets in our data set, but each market will have at least 30 records. So we know we'll get a more or less reliable estimate of average age in those markets. So I'm going to duplicate this sheet again, and now I'm just going to look at average age. I'm going to sort it. So now I'm starting to understand what the distribution of the age is per market. I can see here that oldest users are on average in Sweden, and youngest are in Indonesia, and US is somewhere in the middle with about with users who are about 32 years old on average. So we just saw how EVE can help us verify data quality. It helped us understand. It helped us make sure that the row is what we thought it should have been, that we have as many records and as many unique records as we should have. We spotted some missing data, and we made sure that we didn't have any number format problems. So just want to leave you with something in this section. This is what I learned in many years of work with data analysis. And this is that if something looks wrong, that it probably is. So trust your intuition, check your queries, or talk to someone who helped you build the data set if you see any inconsistencies or anomalies. So understanding shape of data is also pretty important. Among many other things, it can help you focus on the right questions and point you to the right statistical techniques to use. Some of the questions you can ask when using EVE to understand data shape is, what does the distribution of your data look like? Is your data symmetric or skewed? How spread out is your data? Does your data have multiple peaks? Does your data have a long tail? And my favorite chart to use is a histogram, because it can answer all of the questions on the previous page and give you many insights into your data shape in one chart. And the way it is plotted is by separating your metric into equal intervals, and then a vertical bar on top of that interval will show how many records fall into that interval. And here we also displayed a couple of pretty common data shapes. One is symmetric or normal, also known as the bell curve, and it looks like two sides of the histogram are mirror images of one another. Data can also be skewed, and it usually has a long right tail or a long left tail. So let's revisit our question from the last section. How old are our users? In the previous example, we saw that they were about 32 years of age on average with some variation by market. But what does it actually tell us? Are all of our users around 31 years old, or do we have some really young users and really old users, and they just happen to average out to 32? So let's go back to our second data set, and let's build a histogram out of age to understand the shape of that metric. And this is actually pretty easy to do in Tableau. I can just drag age as a sum to rows, and then use histogram in one of the charts suggested by Tableau. And now I have a histogram, which I'm going to turn to pink to match our presentation colors, because that's important. And Tableau also created this variable called age bin. And what it does is it sets the size of the interval in this variable. So in this case, the size is 7.1 years, and we want it to be a little bit smaller, just to zoom in a bit more into the histogram. So I can change it to 5 years, so our histogram is a little bit more granular. And now I can check out its shape. So it looks like we definitely have skewed distribution here. There's a long right tail, and the data seems to be pretty spread out. We have some pretty young users, and we have users all the way to 110 years of age, which is kind of questionable. But then we can also see that most of our users are below 40, and largest share of users fall into 20 to 25 years of age interval, which tells us that we have some younger users. We have a lot of users in their 20s. What kind of products can we build to keep engaging them? On the other hand, we could consider maybe how can we appeal to older audience? How can we market our product better to them, since we under-index in the older users? So let's zoom in a little bit more on this histogram. So I'm just going to change the size of the interval from 5 to 1. And here, some really interesting peaks have appeared. So we're still seeing this curious audience of 110 to 120 years of age, which would be really exciting, but most likely these people just probably lied about their age. And on the other side, I see some very young users, 3 and 4. And to be honest, after seeing my cousin, who is 5, roaming through his tablet with the speed that I could never, ever match, I could actually believe that this one might be true. And there are also some peaks in the histogram which look like they age in 7. So we have 27, 37. It took me a second, but then I realized, oh, we're in 2017. So probably some users just tend to pick the year of birth that ends in 0. So, so we just use DVA to get us to understand our shape of age metric better, and we looked at what the distribution of it looked like. We looked at whether that data was symmetric or skewed. We looked at the spread. We looked at multiple peaks, and we looked at whether our data has a long tail. So this kind of analysis can give us a much more nuanced look into our data compared to just simply looking at average. It can really help us understand our users better and where the opportunities are. So now I'm going to pass this over to Peter to talk about relationships and correlations with EVA.
Great. So I hope you're seeing so far that even with some very simple techniques, we can dig down into data very quickly. This is really important when we're looking at multiple variables. So a lot of us deal with data from humans. Humans have many aspects to their behaviors and lives, and so does the data they produce. And understanding the relationships and correlations between those is something that EVA can help us with a lot. Thanks. All right, so the kinds of questions that we can answer on this topic are 2 or more behaviors connected? Are there any nonlinear relationships? This is something that visual analysis is particularly good at finding, is nonlinear trends that may not be delivered by doing statistical work. Can we identify any clusters? Are there any relationships between certain categories where they like over-index with each other? And can we find clues to causation? We're always saying over and over again that correlation is not causation. But we shouldn't forget that correlation is often an indicator of potential causation. And so finding those correlations is important because then we can go ahead and do things like A/B testing to uncover actual causations. So our best friend for relationships and correlations is the scatter plot. Tatiana's favorite type of chart is a histogram. My favorite chart type is a scatter plot. If you take one thing away from this talk, I think it should be that it's important to have a favorite chart type and stick with it. Okay, so we're going to look at how scatter plots can help us. Let's have a go. All right, so we're going to go through an example for social media. So imagine you are in a platform that has a social media function or is a social media platform, and we're trying to understand, does following more people lead to a higher level of engagement in some measure? And we have a hypothesis that it will, both because it's actually in itself a symptom of higher engagement, but also because following more people might lead to a different product experience. So we're going to use Tableau to investigate this question quickly. Okay, so I have a simplified data source here of users split into groups by how many people they follow. And to try and understand the relationship between follows and engagement, I'm going to quickly create a scatter plot. So I'll do this. And when you create a scatter plot in Tableau without any breakup, it just gives you 1 dot. So we need to break it up by something, and I have this grouping here, which is just my aggregation across different follow levels. Okay, so this isn't really showing as much. I kind of see this as like a dying slug blowing out some bubbles in the air on the right-hand side. It's not particularly attractive. But we definitely see that there are some outliers here. So there's this stuff up here. These might be quite interesting. Now what I'm going to do is I'm going to duplicate this sheet. And you'll see that Tatiana and I duplicate our sheets a lot in this process. And it's something that I really like to do, and I think it's very important because it enables you to keep a track of your path of analysis so that you can always go back to any point that you were at earlier and fork off in a different direction. In this instance, I'm actually going to be getting rid of these outliers, but if I wanted to focus on the outliers, I could come back to that sheet and then keep them only and then go from there. So I really like this as a way of kind of record keeping. So I'm just going to get rid of these outliers from this view because I think they're distorting things. So let me just hover over those and hit exclude. OK. So we're not seeing too much of a pattern yet. This is really just showing me that as the number of follows increases, you see a greater variability in engagement. But I want to bring in some context to this data. And again, that's something that's really important to do if you're looking for any patterns, is to identify where is the context important and where are we dealing with just a small number of people. So I have a field here called users, which is just a count of the number of users. And I'm simply going to drop that onto size. And this is where you'll see it's simulated data. We have some enormous user groups down here at the left-hand side. And we can see immediately that all the stuff on this right-hand side is very small numbers of users. So I'm feeling confident that it's OK to ignore the stuff on this side for now. So that's going to let me zoom in over here. Again, I can just use this lasso. And you'll see us, again, using that a lot when we're doing this type of work, rather than using the other types of filters, just because it's more like part of the flow of analysis. And we've got a big white space. I'm going to get rid of that because with a scatter plot, unlike a bar chart, it does not matter if you don't start at 0. Cool. All right. And now we have a pretty clear view on what's going on with this data. And to me, this is showing something of a nonlinear relationship, which is made up of two parts. We have an extremely linear relationship here between 0 and about 20 follows. And it's getting pretty flat and just varied after that. And something just happened. And we're back. All right. So this is telling me that actually this point of 20 follows is pretty significant. And this is useful information because it means that we can try to understand if getting people to that number will help us to maximize their engagement on the platform. And so we can think about building tweaks to our product or marketing or communication to try and drive people's engagement up to this crucial number of 20. And that's something that we could then experiment upon, and we could also do some user research to find out why that's happening. So again, that was a very quick example, but I think it shows how delving into the data in that kind of way reveals something that you wouldn't have seen from looking at a top-level view. So we covered those 3 points. We saw two connected behaviors. We found a nonlinear relationship, and we found a clue to causation. Okay.
So when you look at data, especially in the historical context, it's a good idea to look for patterns and trends. If you can identify trends that are occurring and any cyclical patterns that have happened in the past, it can go a long way in helping cut through the ambiguity of data and to gain insight into what will happen in the future. And some of the questions to focus on here would be, are there seasonalities at different levels? Can you use other versions of time? It doesn't have to be date. For example, at Spotify, we quite frequently look at days since user registration. Can you discover the order of actions? Can you see the signal through the noise? And what are the trends between the groups? And the line chart is actually a pretty simple and effective way of understanding what trends and patterns exist in your data. They can be pretty effective on their own or in combination with some noise canceling function. So let's imagine we are now working for a web company and we're trying to monitor user engagement over time. So here I have a pretty simple data set that tracks user engagement on all platforms and then separately on desktop and on mobile. And here I'm looking at user engagement on the sheet displayed as for all platforms starting with December 2016 through August of 2017. And it definitely looks like something interesting has happened around Christmas time. We see a drop in user engagement, and we see that that drop actually persists through all of January. So what happened there? Before we start diving into it, I also see some smaller, it looks like weekly fluctuations. And I'd like to get rid of those because noise like this can really pull our eye away from the bigger picture. And this is pretty easy to do in Tableau. We can just apply a moving average from quick table calculations. Didn't help much, and this is because Tableau defaults to averaging two data points. And in our case, because we're trying to get rid of a weekly fluctuation, we need to average it around to average 6 data points. And I can do that by editing the table calculation and changing that number to 6. And it's not 7, actually, as I found out when I was doing this example. So now we have a more clear long-term trend. We got rid of the weekly fluctuations. And now I want to understand what happened in the historical context. So we have the data here going back to 2014. And when I extend the date to 2014, I can see that that pattern we just observed, it actually repeats itself every year around Christmas time. So we see this drop in engagement that goes back up around February. So, so we see this now. We know that this is something we can expect in December of this year, but it still doesn't help us answer the question why that happened. So let's dig in a little bit more. Here, I have the data displayed as engagement on all platforms at the top, and then below engagement with desktop and engagement with mobile separately. And I see here that these fluctuations seem to be driven by engagement on desktop, which kind of makes sense, using computers in the offices, that it could be, the desktop engagement could be more affected by seasonalities. And I can also see that engagement on desktop has sort of been declining over time, and it has been increasing on mobile, which isn't as susceptible to these fluctuations we're talking about. So we just gained a little bit more insight into what happens by platform, but it still hasn't helped us understand what really happened. And this is actually not an easy question to answer, and this could be a great opportunity to turn to our friends in user research and see if they can help us understand what actually went down, what happened. So in this section, we used EVA to understand patterns and trends by looking at seasonalities at different levels, trying to see signal through the noise, and looking at trends between the groups. And now over to Peter.
OK, so our last section is my favorite section, which is using EVA to find things which are unexpected. It's the kind of things that you didn't expect to find. And so they kind of usually stand out from the crowd. And that's why I'm calling these things outliers and quirks. So EVA can help us in a few ways. We can spot extremes in our data. We can also try to identify whether something is a real phenomena or just a data quality problem. We can look for rules, and then we can spot the exceptions to those rules. And then we can try and dig down and find out if those exceptions are actually the real story and where we should be focusing our time and efforts. And are they then a gateway to dig deeper and deeper to find the underlying story? So we're going to look at two concepts in our last example. We're going to look at box plots, which are a great way to compare distributions side by side. It's kind of like a histogram from the top. And we're going to use Tableau to dig into the data. And this is where I think Tableau really shines as a tool, because it's the fastest way to dig into a problem and understand what's happening. So let's do this. Our last example is going to be looking at some Spotify playlists. And you kind of imagine in this scenario that you are working with the playlist editorial team at Spotify, and they're trying to understand what mood they should make a playlist in order to maximize the level of engagement. Please note the giant sign at the top right-hand side that says simulated data. Thank you. All right. So we have a data set here of some Spotify playlists. Let's just quickly see how many we have. We have 399 playlists. OK. So I'm going to build quickly a box plot of streams per user against playlists. This playlist URI field is our unique identifier. Just hit Show Me, build a box plot. And I want to keep it in theme, so I'm going to make it pink. OK, so the box plot quickly reveals to us the spread of the playlists. We can see that the median is about 12 streams per user, and that 50% of the data is between about 9 and 15. So actually quite tightly packed in the middle there. But what I wanted to do was investigate this by mood. So let me duplicate. And I'm going to drop our mood field into columns. And let's just make this a bit bigger so we can see. Cool. So now I can see my mood side by side and have a very quick overview on where they compare with each other. And this is a bit better than just looking at the average, because with the average, you might be missing some of the things like the outliers. So some obvious things we can see. Aggressive is very low. I guess if people are angry, they want to leave quickly. Whereas sentimental and sophisticated are longer. You can read into that what you will. OK, so one thing I also like to do with box plots is try to understand how many of each type there are in a section. And you can kind of eyeball this by looking at the number of dots. But it's actually a little bit more revealing if you throw in number of records. And then we just can dump this level of detail out here, switch to a bar chart. And this just lets me have a very nice one single view of the distribution, but also the size of each of these categories. So I can see that excited is a big category, central is too. All right. Now, I'm pretty interested in this point in excited because we've lost again. And we're back. All right. I'm not sure what I'm touching here that's going wrong, but we'll see. OK. So I'm interested in excited. It's a big category, and it has a few outliers up here that are quite high up as well that I'm interested in. I want to see, are those outliers something that I should care about, or are they something that I should just dismiss and just say, they don't matter? And to do that, I need to bring in some context. So let me duplicate my sheet again, just to keep a track of what I'm doing. And I have a field here called MAU, which stands for monthly active users. And I'll just drop that on the size. Now, actually, that doesn't reveal anything straight away, but sometimes that's because you have to give Tableau a bit of a kick and increase the power of this size so you can start to see where things are. And very quickly, you can see these two great big pink blobs here revealing themselves. So I'm now pretty intrigued by these two big blobs. They have high levels of engagement, and they have high numbers of users. So I want to investigate them further. But I want to do that within the context of what's making them different from the other excited playlists. So let's dig down, duplicate my sheets, and then let's keep only excited. And then I'm going to throw this away and remove this. And for more context, I'm going to bring in the total number of streams, which is here, and make a scatter plot. So very quickly, I was just able to change a box plot into a scatter plot in the same kind of flow of analysis, which is a great way just to keep moving with your data. So again, we can see these two are over here. High number of streams per user. This one's kind of interesting to me as well. High streams per user, but low total. So I have some hypotheses on what might be doing this. One is genre. So I have a field called genre, and I'll throw that onto color to find out. And we can see that they are purple, and pop is also purple. And pop is popular, as we all know, which is no surprise. But that doesn't tell me what's different between these two and all the other pop ones down here. There must be something else that's distinguishing the two. I also want to bring in a bit more context to understand just how important they are in a way that's actually kind of hard to eyeball, which is understanding what percentage of streams they represent. So to do that, I can just hold Command and drop streams onto label, and then turn that streams into a percentage. And I can see that over 50% of the streams are coming from these two. So this is really important that we understand what's happening in these two playlists. And I think that percentage kind of calculation is kind of hard to eyeball from this data when it's just visual. So that's when bringing in the labels really helps. So let's dive some further on here. And I'm going to keep now only my pop playlists, because I want to understand what's different between these two and the rest. And at this stage, we can actually just switch to a table view, because we have a small enough amount of data that we can handle. And I can just sort them by streams per user. And I can start to bring in other pieces of data, like the number of tracks or the number of artists. And I could even take the actual URI and go and find out what that playlist is and what's special about it. Maybe it features certain artists. Cool. So that, I think, was an example of trying to understand how you can get from a large problem to some very specific answers very quickly using EVA. And we spotted some extremes. We found some rules and found that they were exceptions to the rules. We chose to dig down on those particular examples using Tableau. OK, so just the final section of this talk is to wrap everything back together to what we mentioned at the beginning, which is our overall insights process. And I'm going to talk through a specific example from Spotify as well. So this was the overall picture from preparation to exploration, sizing, testing, and monitoring. So first, of course, is understanding the problem. And the example I'm going to talk through is we work in the revenue team, so we were trying to understand how we could make our payment process more efficient for our customers. This is a picture of our checkout page. And what we really want to understand is, are there any people who are landing, who want to pay us, who are somehow failing to do so because they can't make it through the process? So we wanted to collect some data on this. So that took us to the second stage, data preparation. Now, this is the super crucial stage of analysis, maybe even more important than EVA. Getting your data right is well worth spending the time doing so. We typically go through a pattern that looks like this. So getting our data that's core and specific to our problem. And that might be, in many cases, like log data, and it might be kind of messy. So then we try and clean up that data, spend the time understanding which fields make sense to keep and how you should format them. And then aggregate that data. We receive at Spotify 100 billion events per day. It's ridiculous to try and look at that data at that level. So we do things like aggregating over user levels, over day levels, over country levels, etc. We can then add some more context to that data in a few different ways. One is looking at associated behaviors. So in the example of payments, we're going to look at what the user was doing immediately before they hit the payment page. We can look at things that we call dimensions of engagement. So this is how a user is behaving over a longer period of time. In our context, this might be what genres do they listen to? Do they listen to mobile or desktop? We have things that we call dimensions of identity. This is who you are. It's demographics. It's the country you're from. It's the age you are, etc. And finally, we can even attach on survey data at a user level to understand how attitudes might be affecting behaviors. So this is what we did for this example. We took our raw logs from the checkout page. And in that process, we were able to understand what we actually do record and what we don't record, which helps our data engineering team. We cleaned the events, we aggregated to a user level, and we added on a bunch of other data that we had from Spotify and made basically what I like to call a big-ass wide data set to do EVA on. All right, so then we go to the exploratory analysis phase. And go for it. We wanted to be unbiased with this approach, so we looked at basically everything in the kitchen sink against whether people were attempting or succeeding to pay. So we look at things like country, device type, genre, engagement levels, their tenure with Spotify, and the payment method they were using, and whether they had any promotions, and many, many more things. I think we must have looked through about 100 variables in total. And we found some pretty unexpected stuff, actually. One of the things we did find was country was particularly important. And we found that there were some really big differences between a few specific markets. So this is when we reached out to our friends in user research, and we sent a research team to do some qualitative analysis. So here is a photo of some of that happening. We have some actual physical payments in some markets. And this is the kind of information that there was no way for us to discover just by looking through the data. So actually sending teams to different countries to understand how are people paying for things in those countries, what are the particular pain points, was really helpful in understanding where to go next. And then the final piece to talk about is dashboarding. So the product team we were working with also understood that there were many, many more things that they could look at with this data which would help them to maximize and optimize their checkout process. And of course, since we had done all this exploratory analysis, we were able to leave them with a dashboard which was designed in a way that we knew would reveal the most amount of information and enable them through the choice of the charts and the choice of the filters that we would use to make it easy for them to action finding out new insights and also to monitor the changes that we had suggested from our previous insights too. Okay, so we are almost at the end. We're going to ask you a few questions. They're kind of rhetorical, so you don't need to say anything. Imagine you're in a scenario and you've just been given a beautiful new data set. You've done the data cleaning and you've got some questions. What are you going to do with that data set? Are you going to start trying to build a nice shiny dashboard straight away, concentrating on your formatting and your fonts and your color scheme? If you're going to do that, you are going to make Tatiana and I pretty sad. And we'll wonder why we spent this time today. Are you going to get super excited about machine learning and run a supervised learning algorithm for the first time without even looking at the data? I see people do this, and that also makes me sad. If you're feeling a little tired, it might be time for a coffee break. Fully endorse that choice. Or you can take your data and explore it visually. And if you're going to do that, that's going to make us super happy and glad that you came today. Okay, so if doing any of that kind of work is interesting to you, we have jobs. You can apply to join the band. If you also want to work in London, New York, Stockholm, or Boston, it's super cool. And thank you for your time. And I guess we'll go for Q&A. I don't know how we do Q&A. Is there a mic or anything, or do we just... Yeah, okay. If anybody has a question, they can come up to the mic in the middle of the aisle and ask it. All right, if nobody has a question... Oh, someone's coming, someone's coming.
Hi, thank you for the presentation. I was wondering if you had any thoughts on the things that you just showed us today, how you would or would not change them based on the maestro that was introduced at the keynote.
Yeah, so I was watching that keynote and I was like, oh, crap. Half of our next talk is going to be slightly redundant. So I think certainly the stuff that we were showing here in terms of like data quality is going to be a massive help because, as you can see, it's worth spending the time doing that, but right now it is a fairly manual task to go and find nulls, go and find outliers, all those things. So the more that like something like Maestro can help us do that quicker, then I'm all for it. I just wish they'd told us about it before this talk.
I'm David Krupp, and I thought it was a very good presentation. My question is, the point of visual analysis is to better understand the data for yourself, and that's quite a process that you laid out, that you do at Spotify. After you have that knowledge of, okay, I get the insights, do you have an equal type of process to be able to visually communicate that to a broader audience? Or do you see that as something that is separate? To make sure, like, do you take into account the quality of the user or the data maturity of the organization when you're building your dashboards?
Yeah, that's a great question. And yeah, we didn't touch communication at all today, but obviously it's really important. I think we tried to get to some kind of standardized way of doing things, which is basically just being really clear, having very clear charts, not overcomplicating things, regardless of the maturity. I think we happen to be fortunate that we work in a very data-savvy, data-mature organization. We also work in what we call an embedded model. So what we do in our teams is we don't go away and come back. We are literally sitting with the people that we're working with, which really helps with the communication because you can kind of do that in an ongoing way. So your final result, we're still going to make some nice slides. We're going to post them online. We are always going to peer review them, both for content and accuracy and communication style. But we're also going to sit alongside them. And we have some kind of forums as well. Maybe Tatiana, you can talk about those.
Yeah, absolutely. I think we really make sure to invest in education of engineers and designers and other disciplines we work with to help them understand where the data is, where they can go get it, and to sort of like explain the framework and how we work with data. And yeah, there are a few ways, there are a few forums where we try to make sure that any analysis we do can be communicated to the teams we're working with, and even to across different teams, just to make sure that there's transparency in the analysis.
Yeah. Yeah, we have a regular insights forum every 6 weeks.
Every month.
Every month. Thanks.
Thank you. Very similar question. I heard you had a team of about 80 folks, and was just curious about how you worked within the company. You know, your standalone group with product coming to you, or you embedded permanently with them, or just how does that relationship work?
Yeah, we're fully embedded. So we have some very strange language at Spotify, but we have these things called missions and tribes and squads. And basically, people from our team, from Product Insights, are embedded with those teams. So we have an equal representation at every level of product, design, engineering, and insights. And that starts from our leadership level and filters all the way down to the lowest kind of hands-on level. So we're super involved in working with those people basically all the time. We used to, I think, before my time, I think Tatiana will know, we used to have a centralized model, and I don't think it worked very well.
Great. Thank you.
My question's essentially the same, so I'm just going to go ahead and skip. But thank you for an excellent presentation.
All right, thanks.
I had a more, it was a little bit loud, a little bit more of a technical or a non-technical question about the nature of your analysis that you do at Spotify. Obviously, a lot of the demonstrations that you did today is user-focused, and you're wanting a lot of insight as to how your users behave. But I was kind of curious if you guys ever do any kind of analysis on the product itself, which is music. You know, are you actually doing music analysis that might not be user-driven necessarily?
So the answer to that question is we are not in our team doing that, but we do have like music research teams who people far cleverer than I who spend time looking at like the component makeups of music and how they relate to each other and those kinds of things. And that drives a lot of the algorithmic stuff that you see in Spotify.
Great, thanks.
Okay.
So I work in the public policy world, and at least half of my data is qualitative. And it seemed, the majority of the session focused on a lot of quantitative data, which is a lot easier to prep and analyze.
Yep.
I was just wondering if you had any, you work with a lot of user research groups and you have a lot of qualitative data behind the scenes. I was wondering if you had any tips and tricks with data prep or visualizing qualitative data.
Yeah, so we didn't talk about this today. When we talk about qualitative, we have kind of full range there as well. So we have everything from one-on-one interviews and usability studies and ethnographic research through to surveys, which produces data. So survey data is like harder than it should be given how small it is. It's harder to work with oftentimes than database data. My advice is normally to get your survey data into the format of what a database would look like, long and thin. Makes it a lot easier to work with. There's a guy called Steve Wexler who does an awesome blog on working with qualitative data. I'd highly recommend checking out his stuff for how to use Tableau for that specifically.
Thank you.
Okay.
Thanks, guys. Great presentation. I was just wondering what top beginner pitfalls you see for people just getting started with exploratory visual analysis.
Do you want to go? All right. That's a really good question. Gosh, I don't know. Have you got any ideas that maybe might spark something?
No, I mean, maybe on like the data prep side and checking for nulls and stuff like that, somewhere we can get tripped up. I don't know. I was just curious if, folks that you've mentored, areas where they get stuck or, I don't know, going down the wrong path or something and drawing incorrect conclusions and this sort of thing.
I think one thing is, and this is why we showed right at the beginning, the simple thing of like showing the count of user IDs against the count of rows. Just knowing what your data represents in the first place, and it's representing what you think it represents, is probably one of the most crucial parts. So you might think you have one record per user, maybe you have two, in which case everything's screwed from that point onwards. Yeah. So I think getting that first point right is certainly extremely important. And then something else to watch out for is the more you lay on top of things, the more you start running calculations upon calculations, the more things can start to go wrong. What we do quite simply is we start investing a lot of time in peer review. So we basically make sure that if you're doing some work, you have someone else look at what you're doing, and they can hopefully spot things that you didn't spot. And I think that's just a helpful, easy way to see through some of those problems.
Cool. Thanks.
And I can add one thing to that. I think it pays off to take a step back and look at your numbers and make sure that they actually make sense. You know, just because you can see a lot, just like sometimes it just doesn't make sense, and then you go back and check.
Yeah, I did some analysis, and we had like, I don't know, 3 trillion of ad sales in a single day. And everyone was like, wow, that's great. And I'm like, yeah, that is great, but it's probably not true. So just making sure that the highball numbers kind of make logical sense is important.
Thank you.
Yeah.
You referenced John Tukey in your presentation. You just mentioned Steve Wexler.
Yeah.
Do you have any other recommendations on books or blogs?
That's a good question. Not off the top of my head. Can you come and speak to me afterwards, and maybe I'll think about it. Sorry.
All right.
Okay, that's everything. All right, thank you.
Thank you, guys.